If you're in AP Calculus and the unit circle still feels like a bunch of gibberish to rote memorize, it's just the right triangle you already know from SOHCAHTOA stretched past 90 degrees into a circle. And in this video, we're going to explain exactly how it works. If you don't already know me, my name's Brandon, and I've worked with hundreds of AP Calculus students over the years, and basically all of them hate Trig, so this is how I minimize what they have to remember. Let's jump in. At this point, you should already understand how to do basic trigonometry on a right triangle with SOHCAHTOA. The trig functions take different ratios of the sides, opposite, adjacent, and hypotenuse from the right triangle, and each combination is basically a different trig function. We have these 6 trig functions, but these are the most important ones up here. And these work for any angle, almost. The problem is, this only represents a triangle if theta stays between 0 and 90 degrees. If we go outside of those bounds, the triangle breaks down. But that's an issue because almost all the other functions you deal with, x squared, x cubed, e to the x, etc., have an infinite domain, meaning you can plug whatever you want into them. That makes them a lot more flexible and overall a lot easier to work with. But our trig functions only work when theta is between 0 and 90 degrees. So the question is, how can we extend that domain of 0 to 90? And as we look at the triangle, you can kind of see the answer. You see how right here, when theta is really big, like 89.99 degrees, basically the biggest that it can be in order to still count as a right triangle? Well, what if we just went a little bit further? You can see that we break the normal right triangle and it would actually now be obtuse. But if we allow that to happen, we can sort of just keep going counterclockwise around the circle, the unit circle. So there's a logical way that we can extend past that 90 degrees, but the problem is that we don't really have a right triangle anymore. So SOHCAHTOA doesn't really work. Or does it? The trick is that we don't use this angle to build the right triangle. We use something called the reference angle. And when we do that, we can build it in the second quadrant by just dropping a line straight down and using this reference angle for the right triangle. And that works for the entire second quadrant. And if we keep going into the third quadrant, we can do a similar thing. It's just that the way that we get the reference angle changes a little bit. In the third quadrant, we just have to drop the line up towards the x-axis rather than down like we did in the second quadrant to complete a full right triangle where SOHCAHTOA works again. And this process works around the entire third quadrant, and something similar works around the fourth quadrant. That's why all the points on the unit circle are symmetrical with the reference angles. It's just that we have to stop thinking about sine and cosine as ratios of side lengths and start thinking about them as the x and y coordinates around this circle. So there you go. Hopefully that makes sense. And by the way, if you're a student who's going into AP Calculus this year, or you're already in AP Calculus and you're feeling nervous, I help students get on top of AP Calculus so they get A's on their tests and 5 on the AP exam in May. I'm always happy to meet to see if I can help in your situation. If you want to talk, feel free to schedule anytime. The link's in the description.